Good morning. Happy Thursday, everybody. Hope you're doing well. There we go. All right. Got a couple things on tap today. I'm going to finish up talking about exceptions and move into advanced file I/O. Finish up chapter 11. This is pretty cool. And then don't forget, project 4 is coming. Nope. Sorry, wrong class. Project 4 got skipped. That's right. We said nope, no to project 4. I'm getting mixed up with the other class. So, we'll move into exceptions. Let's get NetBeans going here. We talked about a little bit. NetBeans, come on. A little bit on Tuesday. Not too much more to it, actually. A couple things about try-catch blocks that we want to talk about. A couple of the other details there. And make sure that's quiet. There we go. All right. So we'll be able to get moving here. That fire up. How else are things going? So someone has a calc test. That's exciting stuff. Sweet Tea, you got a busy winter, don't you? Oh, dad joke, you got it one. While we let NetBeans load, let me grab this one here. I just got a couple good ones too. Let's see. Yeah. So, I was having trouble with my dog. And, you know, it's a young dog and a little rambunctious. And apparently she likes to hang out in the front yard. And you know, we live on a nice road with the sidewalk. And as people come by, she would apparently has been harassing people. And it got us in trouble because apparently the police came by and they said, you know, we've got a report that your dog's been chasing people on bicycles. And I looked at the officer and I said, Officer, I think there must be some confusion. My dog doesn't have a bicycle. Yeah, calc can be a little bit rough for sure. A lot of stuff to have in your head. Which is, I don't know. I don't like having to memorize stuff. But that's just me. So, man, what happened to all of our nice weather too? Got chilly. What is it now? 49, yeah. Oh, Calc 2, yeah, that's one with all the trig functions, right? You have to memorize. That one I had to take twice, actually. But the second time I did pass it. You know, I think the first time I did pass, technically, it just wasn't a good enough score to give me credit. Or transfer credit, right? I needed, I think, a C or better. I think I ended up with like a D plus or something the first time around. Posture check, yeah, thank you. Here, there we go. Let's put this on, warm up a little bit. I had like, my window in my office is still open and it's cold in here now, which is a bummer. And NetBeans is still loading, my goodness. My goodness. I guess that means we have time for another joke. Okay. This one's pretty good. It's what do you get when you pick a pig's nose? Hey, good morning, Sticks. You get hamburgers. I know, sorry, it's not funny. I'm going to do the final project next week, after we start talking about graphical user interface programs. I think was the plan. That's right, and I am out of coffee. I did not make another pot this morning. I'm very bummed. All right, close that one down. Here we go. Here's our chapter 11 exceptions. Yeah, it should be a lot of fun. Be a lot of fun to get open on that one. Let's see. not assignments. I want the syllabus page. Here we go. Yes, the back button does work occasionally. Yeah, so if we talk about it on 3:30, that gives us basically a month to get going on that. I think that ought to work out well. Not that you guys don't have other things going on in life and other exams and stuff, but I'm hoping a month there should be good. All right. So we did a little bit with some basic exceptions here, right, where we said, hey, we can try, we can catch, and our coffee was just crashing here. Life, yeah. Life, man, life is busy. Life is busy, I'll tell you. Somehow just it sneaks up on you and gets busy. All right. So we looked at this. We've seen this exception before where we fail to parse a number and we get a number format exception. Right? Other things that you can do with try-catch blocks that are pretty cool is you can have more than one catch. And the reason we might want to do that is we could have very specific types of exceptions, and we could get to more generic type of exceptions, all the way up to just a general exception. And we can do a different kind of handling for it. You know, in our case, we'll probably never get here because we know we're going to get this number format exception. We can catch a specific type of exception, and then you can go all the way up. So if you do have more than one catch block, you do want to make sure you're going specific to general, the general type or generic type here. Because if you catch just a general exception first, you're never going to get the specific one. Because it's going to, the first one that it matches, it's going to take. You have to be a little bit careful there. Again, this is probably better when we have larger blocks that we're trying where multiple things could go wrong. Or if we're doing some file input and output, we're going to see in a little bit, you can get different types of file input and output exceptions, right? There's a couple different ones we might run into. So just catching a general exception is not necessarily ideal because it's not going to tell you exactly what went wrong there. Right? Whether or not you couldn't find the file, or you didn't have access to the file, or you get a couple different options there. And then in terms of our exceptions, if we want, right, we said, hey, this beverage is going to throw an illegal argument exception. Not enough left in the cup. We could throw this one in the try-catch block as well. So try and catch. And here we knew it was an illegal argument exception. And then we can print out, you know, the exception there has a message. You can say exception dot get message, and it should print it out. Or even, I think even the toString is decent, but I think get message is usually a little better. So let's try our get message. See if we can get that not enough coffee to drink. Right. Not enough to cup. That's right. So give this a run. All right, enter number. There we go. And now we get our message here. See? There's not enough left in the cup. So we don't crash. We're able to gracefully, mostly, handle that message. Give it a little format. And we can give some sort of response back out here. Again, depending on how we're using this class, what kind of application it's in, we can do something with this message. Right? Just spitting it out to the console only works if we know it's a console application. And remember, our class beverage has no idea that it belongs in a console application. We just wrote a cool class beverage so we could track how much coffee we're drinking in a day, or sure, whatever our situation is here. Okay, so the class doesn't care how it's used. So the only way it has to communicate is by throwing an exception. Don't print messages in your classes. Okay? That is not what you want to do. So this is how a class communicates with the code that calls it, right? So you have the calling code is the one responsible for dealing with the exceptions. And we've got two types of exceptions, really, which is kind of cool. We have checked exceptions and unchecked exceptions. And I know that the distinction is not all that interesting, but you might recall when we were doing some file input and output, if we wanted to go read a file, some file equals a new file, and we said some file.txt, and then we went to open it, and we said scanner file reader equals a new scanner given some file. Do you remember doing that back in 1500? I'm sure that's going to ring some bells for people. Now we get this nice big red line here. Unreported exception, file not found, must be caught or declared to be thrown. And remember what I told you to do for 1500, because we hadn't got there yet, was add a throws clause for file not found exception. We're not going to do that anymore, because we can do better. So this idea here with these throws clause is saying, hey, this exception must be handled. You have to do something with this exception. Right? And it was not going to let us do anything without taking care of that exception. Oh goodness, I'm messing up all my windows here. There we go. Okay, there's our exceptions. There we go. Yep, our checked and unchecked. So unchecked exceptions come from runtime or error types, and they just happen, right? If it is something that is a checked exception, right? A checked exception has to be handled. Hey, it's almost your birthday, Snake. That's awesome. I've got mine coming up in April. I'm pretty excited. So with an unchecked exception, like this number format exception, Java didn't care, or NetBeans didn't care whether or not we had a try-catch block. But with this exception, our file not found exception, this one is a checked exception, and we must handle it. Right? It won't even compile if we don't try and handle it. And we can either add the throws clause and tell the compiler, yeah, sure, we're going to crash, we don't care, pass the buck. That's what we had done before. Or we could actually try and catch. Right? We could do a try and catch block. We could catch a file not found exception. And we could print that's not actually the word, exception.message. Oh, did I type it wrong? File not found exception. I just have to import it. That's right. Yeah, please import. Exception.get message. So obviously we don't have a some file.txt. I didn't write one yet, but that's okay. We're going to see, now that we try and catch, we don't have to add that throws clause. We don't have to tell Java, oh yeah, this one might crash, and be embarrassed about it. Enter a number, and here you go. Some file.txt. System cannot find the file specified. That's not so bad. Or you can just print the message too, the whole thing, and it'll two-string itself. It's a little bit more verbose, right, if you print the whole thing. Enter a number. That's right, I was waiting for you. Here's the whole thing. The name of the exception and then the message. That's not so bad. But this is not all that helpful to most people. Right? For programmers, sure, and it could tell us what went wrong. But this one, maybe not so much. Okay? So with checked exceptions, we have to handle them. We are required. So we did the throws thing. You can get the message. Cool. You can create a custom exception. All right, awesome. I think we're doing pretty good there. Yeah, that's about the gist of it, which is nice. I don't know. I don't know why they stick this all the way in chapter 11. I feel like we could have done this sooner, but maybe not. This sort of makes sense with these try and catch blocks. You can have more than one catch block. And then the last thing that we can do after we have a try and a catch, you can add a finally block. Did I want to record the video this time, Snake? I'm sorry, I'm confused. I don't know if I had enough coffee yet or what. To record a video. I mentioned it last week. I think I was talking about doing your final project presentations and mentioned recordings. Does that ring any bells? So like if you can't make it live on 4/29 in the morning to the synchronous session where you can present your final project, we can do a recording, or you can arrange to present at another time. Where does the exception go after the catch? Ah, yes, thank you. So remember, when an exception happens, code stops running. That's why in our loop up here, we could use this set failed to false, and it only ever runs if we don't throw an exception. If this causes an exception, we jump right to the catch block and code stops running. So if we put our breakpoint here in 21 and run it in debug mode, if we don't give it something that will successfully parse, we're going to jump into a catch block and back up into the while. So we're never going to hit line 21 here. Let's see. So enter a number. Notice it never gets to my 21 here because I'm not giving it numbers. It jumps immediately, like a, I guess like a return statement. Right? It ends there. It stops. As soon as I give it a number, though, now it'll get past that. So an exception breaks our continuous flow of code. And we don't get line by line by line by line. We jump right to a catch. And we could have a bazillion things inside this try block. I don't recommend it. But you could have a ton of things in here, and you'll skip all of them as soon as that first exception happens. It jumps right past it and looks for the catch that matches. And then after the catch, it just keeps on going. So if we don't have a loop here, we just catch and we just keep on moving along. Next, line 39 would happen next. So we can try. If an exception happens, we might be able to catch it with the right type. It's possible you put the wrong type in here, and then you don't catch it either. And then this finally block is used to whether or not the try ran or the catch ran, the finally block will run. So this runs no matter what. Runs either after try or catch. So it always runs, right? Man, one pot of coffee wasn't enough this morning. Got to get that second pot moving. So our finally block can go in here, and we can do any operations we need to do just in case. So if we're in the middle of doing some calculations, maybe we've got a lot of stuff happening in the try block. We can clean those up or make sure we're in a good state here after an exception happens. Let's see, what might we want to do with that? I don't have any good ones at the moment. Yeah, it's not anything interesting in our examples here. Excuse me. Okay. So if we are, let's try this. We'll try file reader. We don't even have a file reader, do we? Okay. That's all right. It's just like the cleanup bit here. I'm sure we'll think of something good to put in there later, but all right. Other thoughts about exception? No? All right. So let's close this project down. Let's start a new project. Do chapter 11 file IO, just to keep this one separate here. All right. So with the basic file IO, what we had worked with was text files, right? Where we could actually open them and look at them and see the text inside of them. So our basic text files, we would use a print writer, like file writer equals a new print writer, and then we would give it a file name, like test.txt. And yeah, we're going to import, and now we don't want to have the file not found exception. We don't want it to throw that. We want to surround with a try catch. Oh goodness. That is a cool little logging thing there. Sure. No, we don't want any of that logger. And we'll just, we'll print out the exception maybe. Okay. So make a print writer, and then we use that, and we get print lines. File writer.print line, just like we've seen, and we can print some messages to it. Basic text file. You open the file, you read or write the file, and then you close the file. We're going to do the same operations with our advanced file IO, but it works a little differently here. Okay, so when I run this one, you get a new file here. Let's take a look, see if we get a new file. That's a little file tab. It didn't actually run. Okay, change our properties. Now we can run it. There we go. Here's our test.txt file. And this has some contents, right? These are basic text-based files. Again, the file extension really is just a convenience. It's just a little shortcut so that if we were to find this in Windows, we would know how to open it. Windows would know how to open it. Still so sad there's not an open button. Really feel like there should be. That's okay. Open. Nope. An opening terminal. That's not what I want. That's okay. But in the text file, we could name them anything we wanted. We could leave it off. .apple, .watch, .opera, .netbeans, whatever. It's just a file handler so that when we double click it in Windows, it knows how to open it. But we can see the contents. So with more advanced file IO, we're going to look at a different type of file. So these ones are the text files. The other type of file we can work with is a binary file. And a binary file doesn't store text. There's not just text that's readable inside of it. What the binary file stores is just raw data, essentially in the binary form. Remember we looked at a while ago in 1500, everything stored as zeros and ones in the binary format. We can store data that way, which is really cool. We've got some good options. And if you've thought about how do we store other types of information, it's kind of hard to store it all just as plain text. Not impossible, but it gets a little bit difficult storing that sort of stuff there. So we're going to work with a file output stream or a data output stream. So our file output stream, it is just the basic, is going to write bytes to a file. Our data output stream gets a little smarter here. We can write primitive types or strings to our binary file, but we have to use it with the file output stream. So we kind of pair these things up. So we'll create a file output stream. I don't know, fstream, sure, why not, equal to new file output stream, and we give it a name. So what do we want to call this one? Here's a test. Now Mr. Gaddis likes, and sure, it's not a bad convention, we'll call it .dat for data, sure. And we got to import this. And this one can throw an exception, file not found exception, so we'll put this also in a try block. Don't need that. We'll print out the exception. Oh, excuse me. Then we hand this file output stream to a data output stream. Because with just the F stream, the file output stream, nope. Right. We don't have a whole lot of interesting options here except for this write method. And you have to write bytes. And we don't really want to have to convert everything down to bytes ourselves. Right? We want to let the tool do that for us. So we don't want to use that directly. What we want to use is the data output stream. Now, like output file, sure, why not? Equals a new data output stream. And then this one we hand the file output stream. Remember kind of when we were doing our print writers, if we wanted to append to files, we used a file writer object. Does that ring bells? We would use a file writer and we would hand print writer to it. So the same kind of idea. We use the file output stream and we hand that to our data output stream. Now the data output stream is a little smarter. We can do some cool stuff with it. Okay? So our output file dot. Now this one has better write methods here, right? We can write booleans, bytes, chars, doubles, floats, ints, longs. A UTF is what you hand a string. UTF is like the formatting specifically for it. There's different types of formatting for strings. This kind of stuff hurts my head, but UTF-8 is our default here. Okay, so we can write a bunch of things, but we need to know what type it is. You can also write chars and hand it the strings there. Okay, or we can get specific about which type of formatting here. Depends on what kind of characters you're gonna handle, really. So let's call write, and now how about we write some numbers to it? Let's write, how about 42 to the file. And we take our output file and we close it. Close, right? So you open it, read or write, and we close. Don't know why those are giving me red lines. Oh, another exception. This is an IO exception. There we go. We only have file not found. So the other thing we can do, we can use a pipe character, which is crazy here. This is a file IO exception. File IO exception, right? TION? That's the type I said, right? And we gotta import that, don't we? I'm probably putting my pipe in the wrong spot. 1 second, sorry. You can have more than one here. No, that should be fine. It just doesn't want to import. Java.io. I'm just going to put a star there. I don't know if you've seen it. We can also do a star import, which imports everything instead of one thing at a time. No, it still doesn't like it. My goodness. It's just IO exception. That's why. It's not file IO. That would be why I couldn't find it. IO exception. No. Doesn't like this because it says file not found exception is a subclass of IO exception. Okay, sure. So this is the parent type. So it doesn't like me saying this or this with that little pipe character. We'll just catch the IO exception. Goodness. Surprise, yeah. Sometimes it's particular. Let's give this a look. We should get our test.dat file here. Here we go. Now this one, when I try and open it, says, hey, it might have binary data. Are you sure you want to open it? Yes. It tries to open it and read it as text. Not very helpful. But take a look. Because it tries to read everything as text, it tries to convert everything to characters. ASCII-table.com? Where's this been all my life? We wrote the number 42. This is like a terrible image of it too. Look at that. 42 is a star. So when I open it up, it says, oh, you have a star here. We don't have a star there. We have the number 42. Okay, we can also then, we can write all sorts of fun stuff here. Output file, .write. How about we write a double, 123.45. Oh, you want 65? We can write a 65. Output file, .write. We write that one as a float. 65. Okay, and we'll run this one. Yeah, I think 65 is A, capital A. That sounds right. It's not the kind of thing we should have memorized, but it is interesting. Now, when you open a file with fstream and output data output stream, it is going to overwrite. So you do need to be careful as well. Yeah, let's try opening it anyway. Cannot be safely opened with encoding UTF-8. Oh, look at that nonsense there. And a stretch. Oh, 65 is a B? It might just be confused. 65 is an A. Not actually a B, but the way that all this data got written, it tries to group it up 2 bytes at a time, right, to turn these into characters, and it doesn't work. It fails real hard. Remember, that's not actually text. Not really text there. Right? It's doing its best to interpret it. It's like, hey, it might be this, right? Now to read a file, this one's mind-blowing here. You're gonna be really impressed here. To read a file, we use a file input stream. And maybe we'll call this one fstream, the new file input stream. And how about we try and read our test.dat file? You know what, how about file input, fi stream for file input? That's still terrible. I'm feeling bad about that. File input stream. There. I'm much happier about that. Uh-oh. An exception might happen. We have to put it in a try-catch block. All right, let's try catch. Not with this, though. Print out the exception. So try and open it, and then we hand it to, because file input stream is not very smart, and mostly we can read bytes. We don't want to read things byte by byte by byte by byte by byte by byte by byte. That sounds terrible. Right, so we're going to hand it to a data input stream. This is my input file, the new data input stream. And we're going to hand it that file input stream. Now my input file can do more cool things. Right, input file can read stuff. Right, it can read booleans, it can read characters, it can read floats, it can read longs, it can read shorts, it can skip. It says don't use readline. It does not properly convert bytes to characters. Don't do it. If you want to do that, you should use this buffered reader thing. We're not going to do that. So let's see. See if we can get this to go here. Let's try and read then an int, a double, and a float. Read int. And we'll say int, I don't know, some value is this. And then we had a double. Oh, right, an IO exception. We had a double, some double value, some int value, some double value, and then some float value. Put file.read double, and a float, some float value, input file.read float. Nope. Input file.read float. Okay, so let's put it in debug mode and see if we can figure those ones out. Or we could just print them too, but let's just see if we can see them in our debugger. Here's our variables. There we go, so some int value, 42, some double, 123.45. Looking good so far. Let's step and get our float. Some float. Oh, I went too far. I'm out of the block now. And as soon as that one ran, it finished. So we didn't actually get a chance to see it. But I feel like it'd probably read it okay. Okay, if we wanted to write some text here, output file dot. Don't use write chars. I want to avoid this one here. Okay, what we're going to do is we want to write UTF. This one is better here. Let me give it some string here, so some message. Because what's going to happen behind the scenes, which is cool, is when it runs, it's actually going to encode how many characters are there. So it's easier to read. We have a string for some string, my input file dot, and we can read UTF. Because it's going to look for these special, hey, how many characters do I need to read, and read that many of them. And let's see, maybe we just print it out, some string. Okay, let's give that a run. And then we'll take a look at our test.dat file. And we got the some message back out. So we open up test.dat. Must be that many characters here in some message. Whatever that formatting is. Okay, so we can read and we can write it. With our file output stream, if you want, here, we could say append data instead of overwrite data. Depends on what option you want to do. Again, it's your choice here. When you create it, you can, by default, overwrite, or we could say, hey, I want to go into append mode with our file output stream, if you want. So, optional argument for append mode. And I don't want to do that because it's going to mess up what I'm expecting to read here, because I know the exact format of what I'm reading. Okay, so we got to be a little careful with it. How you folks feeling so far? These are just basic binary files, writing all of our stuff out essentially as bytes, and then reading it back in as bytes. So you have to know the exact format, which is okay, right? It's not the worst thing in the world because it's our program. We know what format it is when we go open in files and create files. Right? We know, hey, I need to get an int, then I need a double, then I need a float, then I get a string, or however I'm going to be storing that data. Right? I can get it back out in the same order that I put it in. Same type by type by type. You okay? Seem quiet. Okay, cool. Well, why don't we take a break now? There's two other pieces we want to get to here with our advanced file I/O. We'll look at random access files, and then we'll look at serializing objects. And I think we'll be in pretty good shape then for our file I/O, which is exciting, and we'll actually be using this stuff in our final project. Hooray! I know you guys are so excited. So why don't we take 10? It'll put us right about 11 o'clock or so, and then we'll jump into those next types, because those will take a little longer to look at and play with. All right, so I'll put some music on, take 10, and we'll come back here just shy of 11, right? Let's see. I don't know what the seconds is there. Come back in just a minute. Let's go. There we go, 11 even. All right, 10-minute break, and I'll see you folks in a little bit. Alrighty. There we go. Welcome back. Got my second pot of coffee going. It's not finished brewing, but I had to pull it out mid-brew to get my cup. And so I was like, oh, I gotta get back up. Gotta get back up there. So, feeling good. Got some more coffee. Look at that. I've got the complete look today. Right. Got the hoodie. No, that side. I don't know what side of my camera is. That's tricky. The hat and the mug. They still will not give me an affiliate link so I can raise more money for the scholarship fund. Super disappointed that they won't do that, but you know, I'll keep trying here. I don't know. People wear jerseys and jackets and have mugs of their favorite sports teams all the time, so turns out they are a pro chess league team. Right? You guys have heard of the Pro Chess League? Right? ProChessLeague.com. Come on, I know you guys know about this. You folks, you all know, right? We're coming up on a new season soon. Canadian Chess Bras. Or Canada Chess Bras. Okay, because they're from Team Canada. Although they have quite a few people who are not Canadian. But that's, you know, some of the free agent rules, I think, allow for that. I forget what all those particular rules are. Yeah, right. I mean, that happens too. You win some, you lose some. So, more practice, right? Yeah, this was last year's schedule. Now, where's the announcement for the 2021 season? Just representing my favorite team here, best sports team. Nothing. There's no info. They must still be working on that. All right. Anyway, we had some fun. All right, so, not Grey Crow. In Blitz, which is what I mostly play. You know how like people have fantasy leagues for like football and other sports ball stuff? You can have a fantasy league for Pro Chess as well. Pro Chess League, fantasy, and you know, pick your favorite player and see how well they perform. I don't understand how all that works in either sport, so yes, it is. Fantasy sports leagues and the amount of time, energy, and effort and money that go into those things really is crazy. That's correct, Snake. But clearly people have a lot of free time and disposable income. Anyway, those sorts of things boggle my mind, but that's okay. Not everyone is a ginormous nerd like I am, and that's okay, right? It'd be really boring if everyone in the world was like me. Really, really boring. I'll be honest here, right? So, it's good to have a little variety, a little spice. Okay. So, we have talked about binary files. Now, this is still sort of a pain here, having to write one thing at a time and read one thing at a time. That's a lot of work still, okay? But before we get to the slightly better way to do that, oops, that's the wrong window, this one. We'll look at random access files. So what happened here, this is considered sequential access. Right? It read this, and then it read this, and then it read this, and it read this, in order. Boom, 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 boom. So it's great, but say we had like a million things to read, and I wanted the second to last thing. I'd have to read a whole lot of stuff to get there, right? I mean, there's a little, you could do a little bit of skipping here or there, but it's not really what, so this is sequential, right? The other thing we can do, which is really cool, is you can do reading and writing with random access. You can jump to locations in the file. To do that, you make a random access file. Random access file, and we tell it what's our file name. So some file name. Dot, oh, I don't know, random access. Let's try that. Random access.dat. And then you give it a mode. The mode is either reading or reading and writing. So we're going to put this in read and write mode here. So we need a random access file, random access file equals a new random access file. And remember, before I had just imported java.io.star. I'm feeling a little bit bad about that now, so we can be specific about our inputs if we want. Because NetBeans is good for us. Right? If you type the right thing. If you type the right thing. And maybe the star is just easier, but this is not too bad here. Not too bad. There we go. Look at that. And guess what? This one might throw an exception. Should we put it in the try-catch block? You bet. Now, you'll notice I'm doing like separate try-catch blocks for each of these. That's a better habit. Right? You can have everything in just one giant try block with a single catch at the end. But, you know, kind of ideally what's happening here is I'm limiting which exception I'm going to catch here. So like, okay, doing the print writing here might cause an exception. I want one here. Doing the file output for my binary file might cause an exception. I want to catch here. Doing the binary reading might cause an exception. I want one here. Because I want to catch it like chunk by chunk by chunk. If I just have one big try block, I'm not necessarily going to handle it appropriately. And sure, all we're doing is printing the message, but we might be able to do something better. Like, oh, hey, reading that file didn't work. Do you want to try again? Or do you want to give me a different file name? Or all sorts of options here. No, I don't want that logger stuff. I gotta change that too. Okay. This will just be an IO exception, I'm sure, in a minute. And we'll print out that exception. Awesome. So once we have a random access file, right? Read and write mode. Right? If we're going to be writing to the file, right, we want to make sure if we also put it in read mode, it's not going to erase the contents. If we just open it in write mode, we might blow what we had. If you just put it in read mode, it's just going to try and open it, right? So those little options here are really nice. If we try and read and write a file that doesn't exist, it does get created, which is nice. Okay, so again, just be careful with blowing away files or appending to them, depending on how we want to go about that there. Right. So let's see if we can write some data here then, right? We'll take our random access file, and look, we have read options, and we have write options. Kind of like a combination of the reading and writing. Now, these are not smart enough to know, hey, if you just put the file in read mode here, it's not smart enough to tell you that you shouldn't be using these write ones. They're still available. Just bad stuff will happen. It's just going to crash if you try and write to a file that was only open in read mode. So just be careful. So again, we can write, and let's see. So let's write, say, well, let's do those same ones here. Let's try and write the same values. Why not? Okay, so we'll write a bunch of values here. Okay, and then we're going to come back and we're going to read them in a minute. So, yeah, we should be good here. This is good. Let's see. Oh, I forgot to close my file. Random access dot close. There we go. Okay. We should get random access dot dat. Oh, yep, sure. Sure. Looks a whole lot like test dot dat, right? Because we wrote the same stuff to it. Pretty cool, right? So they have the same contents. What we can do for reading, though, if we want to read just particular values out, so before we close it here, or you know what, hey, let's do this. Let's just open it here in read mode here. Let's open our test.dat in read mode. Instead of writing, let's see if you can read some things out. So what I need to do is I need to tell it where to go find this location. So I need to, if I want to read a particular value out, say I want to get right to maybe this float, I need to go jump past the int and jump past the double and go right to the float. So I need to tell it how far I want to seek, right? So how many bytes I want to go. So you have random access file, you have this seek method, and seek takes a long value. Right? Long is just like a really big integer, or bigger integer, right? I want to seek here. So how far in should we seek? Really, this is how many bytes we should go. Well, what, 4 bytes should get us past the integer. Right, let's try that. And then let's try a double value is my random access file dot read double. Right, because we wrote an int, then we wrote a double, then we wrote a float. Int, double, float. So let's see, can we get that double back out here? And print out that value. Let's see if we can do that. So we can jump a certain number of bytes. Look at that, we got our value out. Well, I had said let's try and get to that float here. So let's seek again here then. Now, this will jump right to a position. So if I seek to 0, it's going to put it back at 0, which is the beginning. Sitting at your desk, yep, drinking coffee. So this seek distance here is distance from the beginning. Number of bytes from the beginning. Now, so maybe we wanted to like seek, say, like 100 bytes, and then try and read that. So we'll, I'll just put that back. That's fine. So a double some value is random access file dot read double. Think this is going to work well for us? This has got to work well, right? We'll just try 100 bytes. See how far we get. No, it's not going to work well for us. I couldn't trick you, Snake. EOF exception. EOF stands for end of file. We read to the end of the file. There was nothing left to read. We sucked. What's the seeked? We seeked too far? That was no good, right? Let's see. There's a way. What am I? Size of object. Sought? We sought too far. There you go. And you guys are so much better at English. Size of an object in Java. That's what I want. I don't want any of that. I just want the size. My goodness. That. Oh, goodness. All right, forget that. How many bytes are in a double? That's what I want. How many bytes are in a double? Maybe this first one? I don't know how many bits it takes up. Not the min and the max. Goodness. Okay, my search is bad. Java. How many bytes in a double? 8 bytes. Oh my goodness. Okay, there we go. 8 bytes. So, 4 bytes is our int. If we seek 12, that's an int plus double size. right? So 4 bytes for int plus 8 bytes for double. Then we should be able to read a float. Read float. Float. Floats fit in doubles, so that's why it wasn't yelling at me. This ought to give us now our next value. Remember, so seeking, it just jumps to that location. So seeking 4 doesn't matter. Seeking 12 is what it cares. It reads from the beginning of the byte. The beginning of the byte. So what we actually get here, right? Whiteboard. Do I have one of those? This code here. I have this. Need the hex editor. Okay. There's an add-on for it. There we go. Let's do that. Come on, friends. Okay. This is cool. This is cool. I like this. Come on, my goodness. Let's move. Come on. All right, there we go. I don't know what random files will show up in my computer. I worry about putting names out there is the big thing. I would get in trouble for putting your names out on the internet. So try and be careful if I can help it. What are we doing here? The documents, GitHub. Yeah, I've been pretty good. One time I had to stop and delete the VOD because I screwed up and opened something up in grading mode instead of edit assignment mode, and they had everyone's names listed. I was like, oh crap! But usually it's not too bad. I've learned to be a little more careful here. What am I looking for? There we go. This one. I found it. This one's us. Okay. So we want chapter 11 file IO, and I want to open test.dat with VS Code. And VS Code has a Hex Editor add-on. That's pretty cool. From Microsoft. Look at that. I'm going to install it. Look at that. How cool is that? Super exciting. Open it anyway. Okay, that was that gibberish there. Hex Editor there. We'll install Hex Editing. The Hex Editor allows you to see the binary data, weirdly, in hexadecimal format. That's apparently how you do things. Remember, hexadecimal is base 16, so you get 0 through 9 plus A through F, where F represents 15. It's nonsense, but that's okay. Don't worry about it. Okay, did I install it? I installed it. So I right-click a file, open with Hex Editor. Command palette, reopen with, Control-Shift-P. No, I don't want Control-Shift-P. Hex. Open active file in Hex Editor. Look at that! Look how cool it is. This is the data in our file. Byte by byte by byte by byte. So you can see the first byte, 0, next byte 0, next byte 0. So every byte here is only 2 hexadecimal characters because let's go to our programmer calculator here. And if we go to hex here, right? So with hex, you get A through F. So FF is the biggest possible, likes my files in byte size. Yes, byte size. FF is the biggest possible 2 hexadecimal digit letter, or value, right? Which is 1 binary byte, right? Or up to 255. So every 2 hex values is 1 byte, right? So 1 byte gets turned into 2 hex. So that's why these are all groupings of 2 here. So you see the 2A, 40, on and on and on and on and on. Okay? And what we get here is this little data inspector over here is fun. So the first value here then, through 4, if I grab those 4 bytes, it's telling me, hey, as a particular value here, what's our, I want all of them here, right? Okay, from here, right, this is encoded as different values. So if I were using, say, an int32 or an int whatever, a UTF character, UTF-8, that's what thinks it's a star, right? But we know that's a 42. That's our integer, 42. The next thing in there then, right, was our double. Where was our double? So that was 4 bytes. It's going to be 8 bytes. So 1, 2, 3, 4, 5, 6, 7, 8. 8 bytes here as our double. Right? Should get us, let's see, can we turn that into our double? I know, the calculator's programmer mode, how cool is that? I was pretty excited when I found that out. I want this one as a double. It's not doing that for me very well. Float. No, that didn't work for me. That's okay, but that's where it is here as the double, and then we had our float was 4 more values, right? 4 more bytes. Where do we get that one? We have 66. No, it's a 65, right? So it's not. Oh yeah, it's not an int, but we can see the individual bytes. Then remember when we said when you use the right UTF, you get 2 bytes here to tell you how big a particular value, how many characters it has that it's storing. So some message, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters inside of it. This here, 0C, is 12. Right? We're storing 12 characters. This little 2-byte mark here says, hey, I'm going to store 12 characters of string contents. And it's not going to convert to a number. That's okay. And then our last little end of file mark. Look at that, we reached the end of the file. Boom. This is all the stuff you didn't know you ever needed to know. We're never going to open up and get this level, but like this is what's actually happening behind the scenes, which is really cool that this sort of stuff works. Kind of magic. Anyway, we can jump byte by byte by byte by byte through our file and see you can download stuff off of YouTube. I really should know you could do that. There's probably like a little add-on to do it, right? I feel like it tries to not let you do that. Just need the right tool for the job. Okay, website, yeah. Makes sense. I mean, I can save you, I can export it from Twitch as well, but yeah, that's fine. So if this sort of thing is interesting to you, just because as a bonus thing, I'm familiar with this particular course. And again, just because I'm familiar with the program over here as well. If you do want to continue on and get a degree in computer science, a class that you'll usually take here, let me find it, takes a little bit, where you do all sorts of this fun stuff here, is over at Dearborn, it's 310, which is Computer Organization and Assembly Language. You'll actually write code in assembly, which is, as far as I understand, the lowest level language you can write stuff in, which is really cool. Assembly is actually super powerful. Because it's the lowest level language, it's not the easiest thing to work with, but you can write things that are super optimized. And depending on what kind of software you want to work on, if you get into like particular embedded systems and things, I want to work on circuits and other, even like motor controls and things, car vehicle stuff, right? Not always assembly, but lower level languages tend to work a little better there. So on our desktop computers and Windows, we're a little bit spoiled that we have tons of memory and tons of processing power, and we can do sorts of stuff. But this class was really cool. Talk about digital logical circuits, input output, memory systems, assemblers, assembly programming, computer networks. Computer networks, neat. Like Lego Mindstorm Lego has its own language that you use for programming those. It's a little bit different, but this is fun stuff, and you talk more about bits and bytes as well, which is really cool. Anyway, okay, so you can jump around if you know the size of the things here. So this is cool because I can open up my file and I can jump right to this location and read that location. So if you were to imagine if I were to maybe have a list of bank accounts, and again, people don't do this, but we could imagine, right? If we had a list of bank accounts in a file, I could open it up and I could go find your account information by jumping right to it and not having to read all tens of thousands of customers that my bank might have. Read all of their information. I can jump right to yours. Hopefully, something in your head is screaming database. We should use a database, a database, a database. Yes. A database is the right way to do this sort of thing. But binary files are great for other purposes as well. Right, so I think I showed you folks, if we were to just say, make a new Word document here. Do we look at this, or is this something we did in 1500? Ooh, a rich text format. That's right. I didn't even do Word. Whatever. Formatting's not all that important. We'll put some text in here. Hi there, world. Close it. Now this one, if I were to open up in code, we're not going to open it with the Hex Editor, but we're just going to open it up. Rich text format here. A lot of English looking, or this actually opens here as text, right? We can see whatever all this nonsense is here, but at some point we get big block of blob. That's all binary data somewhere in there. But we got a formatting here. Do we get? I don't think you can find hello, so we can't find our text in there. We can't find hello directly. That's okay. That one's not so bad, but still, it's like kind of a mix of it. If we were to do a new Word document, that's what I meant to do here. Microsoft Word document. There we go. No, Mindstorms is cool. Yeah, I've been wanting to buy a kit, but you do some fun stuff with it. There we go. So let's open up our test Word document now. Let's compare this one to the rich text format. And this one with code. Oh, this one says, oh, it's probably in binary. Yeah, we'll open it anyway. This here does not translate very well. There's still some, like, hey, Word document, something you can see some text in here. You still don't find our hello. Right? Didn't I say hello or hi there? Did I say hi? I don't even know where that's highlighting right now. It says it found a hi. Oh, there. Is that it right there? Hi? That might be it. Yep. So this is all the binary data, which is cool because trying to represent all the things that Word does in a character-based storage is not efficient at all. Right? Remember, storing things as characters, every letter we type takes up 2 bytes. So like this rich text format document here, here's my size. There we go. Takes up 41 kilobytes. And a kilobyte is essentially 1,000. 1024 is proper, but some of the stuff or whatever. About 1,000, you can figure. So 41,000 bytes of information to store hi there world. right? So you can imagine having to store all of this other stuff as characters takes up a lot of storage space. This is not memory efficient, storage efficient here, because we have all this other nonsense in here. Right, so storing stuff just the pieces that we need in that binary form is actually much more efficient. So the Word document here doesn't have all that nonsense. Still has a bunch of stuff here, but that one's only 12,000 bytes or so, instead of 41,000 bytes of all of its binary data that it needs to store here. Okay. All right, that was fun. That was not really... Okay, that's all right. That is okay. All right, let's come on back. The world's best emote snake. I am so glad. It was probably the best $50 I ever spent to get that emote done by a professional artist. I found her on the Knowledge Fellowship on the Discord. I'm like, hey, I need someone to do an emote. So she did that one, and then the sub icons for the little coffee cup that fill up. So it was awesome. So actually, I sent her a picture of myself drinking from a mug from a couple angles, and she put that one together. It was so good. It's amazing, like, I don't know, emotes are so cool. Like this whole thing around emotes and having the cool emotes from the channels. So I think I put that emote in Discord as well, which is cool. And I believe I have the full rights to it. Yeah, coffee. Oh, my pot's probably, the rest of the pot's probably done. I could go get more. That's exciting. You're probably not as excited about the coffee as I am, but that's okay. And this, I don't know, sometimes I feel bad for all these rambling stories and things, but this is the genuine Eric experience. If we were in person in class, it would be just the same. Right? I enjoy going off on tangents and doing silly things. It's part of the fun, right? Part of the fun of learning. No, that's probably quotes fun, right? Fun. Sure. Just finish your cup, you have to make another pot. Oh, man. That's so sad. Yep. Having another pot of coffee is good, though. It's always something to look forward to. Yeah, okay, I didn't have to do the whiteboard of the binary bytes. That's right, we did that. All right, so then the last thing we want to talk about. Don't like coffee. I'm sorry, Scholar. Maybe someday you'll enjoy coffee. It is an acquired taste, for sure. Definitely an acquired taste. All right, the last thing, and this is the most interesting bit here, we saved the best for last, is serializing. Teddy Roosevelt drank a lot of coffee. I believe it. I believe it. I heard a thing, I saw this thing online, and I have no idea if it's true. I meant to ask one of my friends who knows a lot about history. Turkish coffee divorce law. Serializing, yes, making things into cereal. Unrealfacts.com. I might believe this now. This has been confirmed by some suspicious-looking websites online. It's got to be true. Another dad joke. Man, Favanzo, you got it. You got it. I saw this online. I was like, I've got to look this up. If the husband didn't supply his wife with enough coffee, it was legal grounds for divorce. Whew, man. Unrealfacts.com. I mean, maybe real? Who knows? Let's see. Do you know why cowbells became so popular as a way of being able to like hear where your cows are and track them and make sure they're not escaping? That their horns didn't work. So, did I tell you this one already about I've always been suspicious of stairs. I think they're always up to something. I think I told that one already, didn't I? Let's see. Oh yeah, and I had to break up with my gym. It just wasn't working out. uh, this one's cool. So the adjective for metal is metallic, but not for iron, which is a little bit ironic. All right, so let's talk about serializing objects here. So what's cool is if you have an object that is serializable. Oh my goodness, this is so hard to say. It means that you can write it to a file. To do that, we use an object output stream. Go figure. So a file output stream. This is my object. We'll just call it file output stream. Output stream equals a new file output stream. And let's call this one objects.dat. Okay. And now, yes, I want this in a try block. I'm going to do my own try block here because I keep getting frustrated with what they give me. Catch IO exception. We'll just copy paste. Okay. Then what we hand a file output stream is we hand this now to an object output stream. Output stream. Object output file is a new object output stream given the file output stream. Oops. Not with curly braces. I don't know why I did that. My favorite thing to serialize is milk, 2%. You know, I grew up with skim milk, and I would refuse to drink 1%, 2% whole milk because I could like taste the fat in it. But since having kids, apparently the kids need fat. It helps them grow and gives them energy and all that good stuff. So we've only had whole milk in the house for like almost 12 years now. My daughter's almost 12. Although we didn't have milk when she was young. So probably about 11 years or so we've had whole milk in the house. And I've learned to drink that. I still prefer skim, but I can drink the whole milk now since that was the only milk available. And occasionally I do buy a gallon of milk just for me because all the kids hate skim milk. But I'll drink that. Or soy milk, which is supposed to be better for me. But that's not so bad either. Has less sugar, turns out. The actual cow milk is rather sugary. Snakeblood, you are funny, my friend. No, I've put on the Quarantine 25. Yeah, it's deliciously watery. I mean, it is. It really is. And refreshing. I mean, I drink lots of water. It just happens to be filtered through coffee beans. Still water, right? You just pour through some beans. So anyway, it's an object output file. Object output file. You can write stuff to it. You can write all these other things here, but what we want to do is we want to write our object to it. Coffee is better water. So what we want to do, no. Other one. This one over there. Bean broth. You're saying this is coffee is soup? It's essentially soup? We say write object. And we have to give it an object to write. So let's go write an object here. Let's go make a class. Bean broth is our class here. We'll have a private string for name. We'll have a private int for, I don't know what, volume maybe? Or current volume. Current volume. Okay. And let's go and insert a bunch of code. We'll just make a boring class here. Make a constructor. Takes those things. We'll add some getters for those things. Okay. We got our bean broth here. For current volume. Oh, we need a max volume, don't we? Private int max volume. I'm feeling bad now. We should also have max volume. Okay, so actually this should be then max volume. We'll set max volume, and then we'll set current volume to 0. Why not, right? And we should add a max volume. insert our getter for max volume. Oh, you know what? Maybe it should take a current. Why not? Why not? We'll take a current. Because I want to be, if I want to be able to save this to disk, I need a way to restore that value. If I don't have a way to set the value directly, then I'm going to run into trouble. Because if it always starts to 0, I'll never be able to restore what it is. Hey, I love this bean broth. That's a hill I will die on. Bean broth. All right. You know, it's not a bean though. Right? A coffee, it's really the seed, isn't it? Coffee's not a bean. We call it a bean. Is coffee a bean? Ooh, those are some weird suggestions there. Is coffee a... Okay. Coffee or die? Black Rifle Coffee. How about this? It's the seed of the coffea plant. Oh, the blessed plant. So it's really a seed. So it's juice then? You're saying it's fruit juice? Okay, so we want to write. So we need to make a new bean broth object. Eric's coffee. There's a new bean broth. And we'll call this one, I don't know what this is, black coffee, current volume. I've got like maybe 6, I've probably got like 20 milliliters left out of 250 milliliters. And let's try and write our bean broth object. Seed broth, hot fruit juice, I like it. Let's try and do this. So let's see if we can run and write our object out here. Uh-oh, not serializable. Serializable. That's the kind of serial we were talking about with an S, like serial, like in a row, right? So to serialize something means to turn it into bytes, right? So we can read it and write it. It's not serializable. Oh, goodness. Goodness. Okay, well, so what we need to do then is we need to implement a method. I'm spitting here, I'm sorry. I'm getting excited about my hot fruit juice. So to do that, we go to our class and we say implements serializable. Serializable. That's it. There are no methods of serializable. Nothing to implement. It doesn't yell right away. By implementing the interface, we're telling Java, yes, we expect to be serialized. That's it. Okay? If we have fields here, our private instance fields, they also must be serializable. Good thing string already is, and primitives are as well. So it's all the way down the line here. So everything down the chain has to be serializable to make your class serializable. Okay, but now we should be able to write it. Look at that. Let's take a look. Do we have an objects.dat file? We have an objects.dat file. Let's open this one up with VS Code and take a peek. Right, we're expecting black coffee, 20 and 250, somewhere in there, right? Because those were my attributes. Right, the methods don't have to be serialized. That belongs to the class definition, but the data itself, the instance itself. Let's do it with the text editor, Hex Editor. Hex, text. Man. Hydration, thank you so much. Thank you. Look at that. Oh, okay. Bean broth, current volume, max volume, name, string. Look at all this cool data in here. Black coffee. Look at that. There's some cool stuff here. So let's take a look at current volume. current volume. Let's see, is it a 9? I didn't tell it 9. What did we tell it? We told it 20. Okay, so something, there's not a 20 there. Let's see, where else would there be a 20? I'll look for a 20 in here. That one? That's 13. No, that's not a 20. 4? No, that's not a 20. 18? Nope. Not seeing it there directly. How do I drink my fruit juice? Oh, black. That is the only way to drink your hot fruit juice. And a stretch. Yeah, I thought I told you guys, or did I tell the other class about the story of my first job? And the boss was the only one who took cream and sugar in his coffee, and everyone made fun of him for it. And there was no drinking fountain. Although back then I used to drink a lot of Mountain Dew as well. But actually, okay, so I used to drink a lot of Mountain Dew when I lived at home because my parents would buy the Mountain Dew. When I moved out and got my own apartment, I stopped drinking Mountain Dew because it cost $3 per 12-pack. And as someone who had just moved out and had to pay apartment rent and all sorts of other things, $3 for a 12-pack was a lot of money. Half and half is okay. Yeah, for sure. Yeah, the sugar part's bad for you. I'm diabetic, so the blacker I can drink my coffee, the better for me. Anytime I have sugar, I have to go and take a shot and stab myself. So, with one of these guys. Oops, one of these ones here. Come on, come back. So, thankfully to the marvel of modern science, and, you know, $100 per pen here, I don't die, which is good. Anyway, so this is serializable. Has some information about the class here and about the instance. So we've serialized this. Now we can go if we can go read it. Okay? But we want to see if we can read our object. So we wrote it, now we want to read it. Okay, so we're going to, again, we'll do a try block here. Because bad stuff could happen. Again, we're just going to catch, sure. So we want a object. So I'm going to say bean broth, input bean broth. And I'm not going to create an instance of it. I'm just going to declare it here. And then we're going to go make a file input stream. Right? This is my file input stream. There's a new file input stream. Now, this is the interesting piece here that we're actually going to be doing at the project. So throw is what triggers the catch. So you throw exceptions, and if something throws an exception, you catch it. So try says something might happen. I want to catch it if it happens inside my try block. And then it'll get caught in the catch block if the exception type matches. This is objects.dat. And then we need an object input stream. This is our object input file. Equals a new object input stream. Given the file input stream. Okay, all of that now to say my input bean broth is equal to my object input file dot read object. Oop, but now it says it doesn't match. Object read object gives you back a type of object. So what we have to do, we have to say, oh, no, really, I want this as a type of bean broth. Bean brother, no broth. Right? We're going to cast it as type of bean broth. Say, hey, this object thing that you read, by the way, you are really a bean broth. Let me treat you as such. Class not found exception. Ooh, there we go. Neat. There's a new one. So let's add a catch for class not found exception. Here, this one I think we can OR. Here, we can do this cool pipe thing. They catch that one or that one. There we go. Because we do the same thing. So this is this type or this type. It's a weird operator here. Bad stuff happening. Your mind is panic. My mind is nay. Sorry, Snake. So we're going to try and read that bean broth here as our input bean broth. And then let's just output our input bean broth. Yeah, I'm actually just put it in debug mode, but I need a line here so I don't skip past it. Let's see if we can read that from our file. Now again, I still need to know the order in which these things are written, right? If I'm going to write 10 different objects, right, I need to know, okay, this object first, this object, then this object, then this object, then this object, then this one, then this one, then this one, this one, this one, this one, this one, on and on and on and on. Oh, we don't need a breakpoint here. Sorry, we can continue. There we go. Now we've got our input bean broth. Let's take a look. Did we read it correctly from our file? Name is black coffee, current volume is 20, max volume is 250. We're able to read the information out of our object. How freaking cool is that? Just by putting this little stupid tag here, saying, hey, we implement serializable. We are serializable, by the way. We're able to do it. Now, there's a little bit more magic that has to happen behind the scenes, but it's close. Don't worry. We'll talk about some more of that magic later. Okay, we are about done. Yeah, you know what? Let's see. Let me do that. Let's go back. Let's say here, if we had ways to interact with this, right? So let's add our fill and our drink. So public void fill means my current volume gets set to the max volume, and then drink, right? So not everything will serialize correctly. Right, so it's by implementing it, you're saying, yeah, I've checked this little list of things to make sure it will happen properly, because not everything can be serialized well, and we'll look at that in just a second. That's what we're going to play with here. Let's see. I think I even had all that over here. Didn't we have that over here? I don't want to have to reinvent the wheel. Oh, ours was beverage. It wasn't bean broth. There we go. Look at that. Look at that. We're just going to steal that. Put that in over here. Current volume. Oh, now I'm feeling bad. That should be current volume in milliliters. Okay. So, okay, sure. Let's refactor, rename to current volume in milliliters. Good. Keep the word in milliliters. Let's refactor, rename. Max. Oops, no. Max volume in milliliters. Refactor. Oh goodness, it didn't change my current volume. Refactor, rename. Did I do it wrong? I might have missed it. Let's try that. Okay. Current. So now again, let's take current out, or just take a max here, and we'll set current to 0 when we create this object. We can fill it, we can drink it. Okay, you know all the gets. Now let's see what happens. So now it's going to be unhappy with me. Where did we make our bean broth? Right here. We can't give it 20. We'll say it's 250, and then we'll drink some. We'll take Eric's coffee, and we'll fill it here. Fill. And then we'll take Eric's coffee, and we'll drink. Let's say we drink maybe like 50 milliliters of it here. So if I have 250 and I fill it, and I drink 50, I should have 200 left. Right? So let's run that. Uh-oh. Do I have errors? Should be fine. I fixed that one, didn't I? Oh, I ran it. I forgot to put it in. This was supposed to run in debug mode. Stop. Okay. One more time. Debug mode. Let's see what we get when we serialize bean broth. So now you'll notice our constructor only has name and max. There's no way to set current volume. The only way that current volume changes is by fill and drink. Okay, so we'll come back to our project, and we'll see when we have serialized it here, my input bean broth, we get the right value out. Look at that. That's magic. Right? It's able to create it here, and I now have 200 and 250. Life is good. Even though there's no constructor that takes that. That's pretty magical. Okay. How are we feeling so far? Making sense? Oh my goodness, we are over time. I'm sorry. I was having too much fun here. Oh dear. All right. Well, let's go send a raid out somewhere. We'll go say hi, pester some other people. Let's see. Who have we been visiting lately? Gaming helps memory. That's Site Queen. We've got to go check out that. I am a full believer in gaming. We'll go check out our friend Site Queen from the Knowledge Fellowship. She's amazing. Go learn some stuff. Yeah, today was fun. We'll talk Tuesday about our final project, and we'll get into GUI applications. It's a lot of I/O. All right, folks, take care. Keep in touch. Let me know how things are going. See you soon.